Good morning all. Do you know there's a sport where every millisecond of reaction time and every gram of width can decide the winner? That is badminton, one of the fastest racket sport around the world. In badminton, the racket frame is far more than just a ring around the string. It's also the backbone of every shot. It helps to maintain the shape, support the string, and determine how efficiently the energy is transferred when the shuttlecock is meet with the strings. As shown in the diagram here, the frame is the one that surrounds the head of the racket that gives the racket its personality, its power and stability. Because of this, examine the key property of the frames becoming essential as it directly shapes how the player can perform in the match. The first key property is the width. With a high width frames, it can be more stability and help the player to more control on the long shot. However, it swings more slowly and requires the greater muscle strength to handle effectively. On the other hand, the light width frames is easier to handle and provide faster swing, making it ideal for quick reaction and rapid exchange at the net. Thus, choosing a right width is essential depends on every player's strength, speed, and their own styles. The second property is toughness. The high toughness means the better shock absorption during the impact and offers the right amount of elasticity. This quick elastic response helps to produce a faster racket recovery, giving the player an advantage on having a quick response and speed, having the speed racket optimal. And the third property is durability. The high durable frame can withstand the strong force during the matches, the string tension, and even accidentally crashes during the double competition with their partners. This means that the rackets last longer and has a lower risk of breaking during the game. Thus, having a good durability badminton frame is essential to ensure that the player can rely on the equipment throughout regular training or competition. The fourth key property is the fatigue resistance, which is the frame ability to endure repeated stress over the long period. Badminton involves the continuous impact of the fast swings that will cause and place the cyclic stress on the frames, and having a material with good fatigue resistance is essential because it helps to maintain the performance consistently over time, even in the intensive games. And the last but not least, corrosion and rust resistance, especially when rackets are used outdoor or in the humid environments. A material that resists corrosion maintain the strength, appearance, and structural integrity for a longer time. This ensures the racket performs reliable whether the frame is training indoors, outdoors, or in the area with high humidity. In conclusion, performance of badminton racket frame depends on these five material properties: width, toughness, durability, fatigue resistance, and corrosion resistance. Now let's pass to Agnes.
Good day everyone, I'm Agnes. So now I will be presenting a detailed comparison of three materials commonly considered for high-performance sport equipment, particularly badminton racket frames. First is T11000G carbon fiber reinforced polymer, which short for CFRP. And second, T6AL4V titanium alloy, and also 6061T6 aluminum alloy. All of the information I will present comes from verified materials data and industry reference. Let's begin with a brief description. TR1000G is an advanced intermediate modulus carbon fiber developed by Toray. It is widely used in aerospace and high-performance equipment because of its superior tensile strength, high stiffness, and strong fiber matrix adhesion. Technologies such as Torres nanoalloy further enhance its toughness. In composite application, TR1000G is most commonly combined with an epoxy matrix, although it can also be paired with other thermostatic resins such as phenolic, polyester, or vinyl esters depending on performance requirements. T6AL4V, on the other hand, is a high-grade titanium alloy containing around 6% aluminum and 4% vanadium. It is known for exceptional mechanical performance, outstanding vertical strength, and excellent corrosion resistance. 6061T6 aluminum is a heat-treated aluminum alloy known for its good strength, ease for manufacturing, and corrosion resistance. It is used from bicycle frames to industrial components due to its balance of lightness and durability. Now, let's compare toughness, or how well each material resists sudden impact. T11000G composite has moderate toughness, while nanoalloy technology improves it. CFRP materials can crack or snap under sharp, localized impact. Hidden internal damage such as matrix cracking or delamination, can occur even if it's not visible. T6Al4V clearly leads in this category. It has very high toughness and can absorb sudden energy extremely well. Titanium resistant to cracking makes it the most reliable materials under dynamic or short loading condition. Finally, 6061 T6 aluminium has only moderate toughness. When impacted, it typically dents or bends rather than cracking. Its toughness is lower than titanium and carbon composite. So we'll look into weight, which is density. Density is a critical factor for a badminton racket. T110G is the lightest with a density of around 1.79 G per cm cube. This extremely low weight is the main reason it dominates high-performance sporting goods. Titanium is much heavier at about 4.4 G per cm cube, which makes it almost 3 times denser than carbon fiber composite. This weight is a significant drawback for racket design. For aluminium sits in between 2.7 G per cm cube, lighter than titanium but still noticeably heavier than carbon fiber. A frame made from aluminium will still end up too heavy for a high-performance play. Fatigue resistance is the ability to withstand millions of loading cycles. For T100G, it performs excellently. It can withstand millions of bending or flexing cycles with minimal degradations when stresses are kept within design limit. It retains over 80% of its strength after 10 power 7 cycles, making it ideal for repeated racket swing. Titanium also has excellent fatigue resistance. It has endurance limits around 0.60 MPa even in high cycle conditions, with only minor strength loss after up to 10 power 8 cycles. This is a major reason for its use in aerospace application. For aluminium, however, has the lowest fatigue resistance of the three. It lacks a true endurance limit and shows significant reductions in fatigue life, especially in corrosive environments such as chloride solution. All three materials resist corrosion, but in different ways. T110G composite offers excellent corrosion resistance. The epoxy matrix protects the carbon fibers, keeping moisture and chemical out. T16Al4V also performs excellently, forming a stable oxide layer that shows it even in environments like saltwater. 6061 T6 aluminum has good corrosion resistance, but is prone to pitting in chloride environments. It is also susceptible to galvanic corrosions if it comes into contact with carbon fiber. In terms of general durability, T110G is strong and stiff, but sensitive to impact damage, especially from crashes or hitting the ground. Titanium is extremely durable, high resistant to wear, and maintains its performance even under harsh conditions. Aluminum is moderate durable but can deform or wear much more easily. For structural stiffness and strength, T110G has exceptional tensile strength of 7,000 MPa and a modulus of 324 GPa. So for this, T110G clearly dominates in strength to weight performance. To conclude, T110G is the base material for a badminton racket frame due to its unmatched combination of lightness, stiffness, and fatigue resistance. Titanium, although extremely tough and durable, is far too heavy for this application. Aluminum is affordable and easy to manufacture, but too heavy, too soft, and lacks the fatigue life and stiffness required for high-performance rackets. Therefore, for modern high-performance sport engineering, T110G carbon fiber composite is the ultimate choice.
Since our selected material is carbon fiber reinforced polymer, which is CFRP, we will discuss on its long-term sustainability while comparing it with titanium alloy and aluminum alloy. CFRP offers excellent performance, but its environmental impact is significant. Its embodied carbon footprint is one of the highest among three, which range up to tens to more than 100 kilograms of carbon dioxide per kilogram of material. This is far higher than titanium alloy, which are typically around 5 to 12 kilograms, and aluminum, which drops down to 1 kilogram if recycled. A major issue with CFRP is its limited recyclability. Although technologies like pyrolysis and solvolysis exist, they require specialized facilities and often lead to downcycling instead of closed-loop recycling. This means that most CFRP waste ends up in landfill. Because CFRP is not biodegradable, it can persist for decades and may contribute to microplastic like fiber pollution. From a socioeconomic perspective, CFRP has both advantages and challenges. The first issue is repairability. CFRP damage typically requires specialized tools and trained technicians, which can increase the maintenance costs. However, its high durability and fatigue resistance means that failures are less frequent. CFRP also has the highest material and manufacturing costs among the three options because it requires skilled labor and imported raw fibers. Titanium has moderate costs while aluminum remains the cheapest. Despite this, CFRP supports a growing high-tech manufacturing sector. However, it lacks a widespread recycling industry, which limits the circular economy potential compared to aluminum. Finally, from a user perspective, CFRP delivers the best gameplay performance with lighter weight, higher stiffness, and better energy return. This makes it highly valuable in competitive and professional sports markets. For this reason, despite its environmental drawbacks, CFRP remains our selected materials, as its performance advantage and long lifespan outweighs its limitation and provides the best value for players. In conclusion, our material selection of T1100G CFRP offers the perfect balance of elite performance and durability. It is lightweight and high stiffness, which makes it ideal for fast-paced gameplay, while excellent fatigue resistance ensures a long service life, reducing the need for frequent replacement. Additionally, emerging recycling initiative for CFRP helps to address the sustainability concern, providing socioeconomic benefits without compromising performance. Overall, CFRP is a choice that balances high performance and environmental responsibility. And that is all from us. This is our reference. Thank you.